Hello everyone, I'm Rilo, and in this module, we'll be discussing cross-product. Let's dive in. By the end of this course, students are expected to have these abilities. 1. Demonstrate vector operations, and 2. Apply the concept of vectors in geometry. The definition of a cross-product, if U equals to vector U1, U2, U3, and V equals to vector V1, V2, V3 are vectors in 3 space. Then the cross product U cross V is the vector defined by U cross V equals to vector U2 V3 minus U3 V2, U3 V1 minus U1 V3, U1 V2 minus U2 V1. Or in determinant notation, we have U cross V equals to the vector. The first component is the determinant of the matrix U2, U3, V2, V3. The second component is minus of determinant of the matrix U1, U3, V1, V3. And the last component is the determinant of the matrix U1, U2, V1, V2. And keep in mind that the cross product is only defined in 3 space, not in 2 space or otherwise. For the geometric interpretation, if theta denotes the angle between U and V, then the norm of the cross product is the norm of U cross V equals to the length of U, the norm of U, times the norm of V, times the sine of theta. And if you look at the figure here, the parallelogram determined by U and V, the vector U and the vector V, has the base, which length is the length of the vector U, and the altitude is the length of V times the sine of theta. Hence, the area of the parallelogram is given by the A equals to base times the altitude, or since the base is the length of U and the altitude is the length of V times sine theta, this formula is the same formula as the norm of U cross V. For example, if we want to find the area of the shaded triangle here, we can see that the area of triangle is 1/2 of the area of the parallelogram defined by the vector P1, P2, and P1, P3. Where P1, P2 we can calculate as minus 1, minus 2, 0, minus 2, and 2, minus 0. And the vector P1, P2 is minus 3, minus 2, 2. And P1, P3 is, we can calculate a similar way, 0, minus 2, 4, minus 2, 3, minus 0, or minus 2, 2, 3. And the area of parallelogram can be calculated using the norm of their cross product. Now if we calculate the cross product of P1, P2, and P1, P3, we have the first component is the determinant of the matrix minus 2, 2, 2, 3. The second component is the minus of the determinant of minus 3, 2, minus 2, 3. And the last component is the determinant of the matrix minus 3, minus 2, minus 2, 2. For the first matrix, we have the determinant minus 2 times 3, minus 2 times 2. And for the second matrix, we have minus 3 times 3, minus 2 times minus 2. And the last matrix, we have minus 3 times 2, minus 2 times minus 2. Completing all the calculations, we have minus 6 minus 4, and then minus 9 plus 4, and then minus 6 minus 4. Or the final result is minus 10, 5, minus 10. Hence, the area of the triangle is A equals to 1/2 of the norm of the cross product P1, P2, and P1, P3. Since the norm of cross product is the area of the parallelogram constructed by the P1, P2, and P1, P3. Or 1/2 times the square root of minus 10 squared plus 5 squared plus minus 10 squared, or 15 over 2. So the conclusion is, first one, if U equals to vector U1, U2, U3, and V equals to v1, v2, v3 are vectors in 3 space. Then the cross product u times v is the vector defined by as follows, or in determinant notations, u cross v is equals to the first component is the determinant of the matrix u2, u3, v2, v3. The second component is the minus of the determinant of the matrix u1, u3, v1, v3. And the last is the determinant of u1, u2, v1, v2. And if theta denotes the angle between u and v, then the norm of the cross product is the length of u cross v equals to length of u times the length of v times sine of theta. Alright everyone, that wraps up our discussion on cross product. Thank you and see you in another course.